we have here an example of rational inequality. X all over x minus 2 greater than 1 all over x plus 1 to solve and find the solution set for this inequality. How do you go about that? Now, if you look at it carefully, we have this expression greater than this expression. Now, the only way forward is to carry this expression from the right hand side to the left hand side first. We cannot go ahead and carry out cross multiplication. That's not allowed because this is inequalities. So we take this expression from the right hand side to the left hand side. So we're going to have x all over x minus 2. Bringing this way become minus 1 all over x plus 1. Now greater than 0. We now have 0 on the right hand side. Now we bring all of this to a common denominator. So we have to get the LCM of x minus 2 and x plus 2. That LCM will just be their product. Okay, it will just be their product. Now this product divided by x minus 2 will cancel x minus 2 and we're left with x plus 1. Multiply to the numerator to have x into x plus 1. We take this product divided by that, x plus 1 will cancel x plus 1, we're left with x minus 2. Multiply to negative 1, it will become negative into x minus 2, greater than 0. Alright, we open the parentheses up there, x multiplied to x, we're going to have x squared. X multiplied to 1, we're going to have x. Negative multiplied to x, negative x. Negative multiplied to negative 2, we're going to have positive 2. All of that divided by x minus 2, x plus 1, greater than 0. Alright, we're at this point. If we look here, we have x minus x. These ones, they disappear. It gives us 0. So we're going to have x squared plus 2 all over x minus 2, x plus 1, greater than 0. Okay? So our rational inequality becomes this. Now, take a critical look at the numerator there. We have x squared plus 2. Now, this simply means that no matter the value of x, this numerator will always be positive. Remember, x is squared. So even if we take a negative value, the moment we square a negative value, we are going to obtain a positive result. And then plus 2 again, positive will always give us positive. That means that this numerator has no much role to play as far as the sign of our inequality is concerned. It's not going to affect the sign of our inequalities. So the members that will affect the sign of our inequalities will be this denominator. There will be values of x for which this expression will be positive. There will be values of x for which this expression will be negative. The same for this. There are values which will make this one positive. There are values of x which will make this one negative. So these are the expressions, this and this, that will affect the inequality sign of this rational inequality. So we're going to analyze our work using just the denominator. All right, to do that, we'll find what we call the critical points. Now, how do we get the critical points? The critical points are gotten by setting this to 0 and solve, setting this to 0 and solve. So we set x minus 2 to 0, and when we solve, we'll have the first critical point as x equals 2. We'll also set this one x plus 1 to 0, and when we solve, we'll have the next critical point to be negative 1. Now that we have our critical points, we carry out our analysis on the number line. We place those points on the number line in the right positions. Negative 1 is to the left, and positive 2 is to the right. So we're going to obtain 1, 2, 3 zones of possible solutions. Okay, our solution could lie here, or lie there. So we have to test values in these different zones to see which one will give us our solution set. All right, let's proceed. We take a value in this zone. A good example could be negative 2. Remember, when you are progressing this way from negative 1, the next is negative 2. So a value here could be negative 2. We could also take negative 3, negative 4, negative 5, and so on. So let's take negative 2, and our analysis is here. We're already seeing that the numerator has not much role to play. So our analysis is on this product. How do we carry out that analysis? Now let's write the product here, x minus 2, x plus 1. So when we take negative 2, we are putting negative 2 here. Negative 2 minus 2. We see that our result is negative. And negative 2 plus 1, our result is negative. Alright? Negative multiplied to negative, positive. Since we are only interested in the final sign, here we have positive. Now let's take a value in this zone. A good example could be 0. We know 0 is in this zone. 0 is between negative 1 and positive 2. 0 is one of the members in this zone. Alright, let's take 0 and put in that same analysis. Alright, if we put 0 in that analysis, we're going to have 0 minus 2, negative 2, 0 plus 1, positive 1. Our result is negative. Alright, so here we have negative. We take a value here, for example, positive 3. If we take positive 3 and put there, we have 3 minus 2 is positive 1, and 3 plus 1 is positive 4. So our result is positive. So here we have positive. All right, that is it for our analysis. Okay, so now which of these three zones therefore will give us our solution? We look here. What we have here, we have greater than 0. Remember, on the number line, this is 0, this is greater than 0, this is less than 0. Values to the right of 0 are positive. Values to the left of 0 are negative. So when we say greater than 0, that means to the right of 0. So we're looking for where we have positive. Here, so our solutions will lie here or here. Our solutions will lie either here or here. So to conclude, therefore, we're going to say our solution set will be all real values of x such that x is either less than negative 1 or x is either less than negative 1 or x is greater than positive 2. Okay, so this gives our solution set for this rational inequality.